Okay, so to finish our schematic parametric model, we're gonna go ahead and create the basic geometries for our slabs, glass curtains, and handrails of our tower. So to do that, let's go ahead and get started by creating some planar surfaces from our rotated curves. So I'm gonna go ahead to my surface tab, and then under my freeform subcategory, I'm gonna select my boundary surface component. And I'm gonna go ahead and plug it into my rotated curves that I have over here. Then we're gonna grab these surfaces and extrude them to create some slabs. So we're gonna go again to our surface tab and call an extrude component. And I'm gonna also go to my vector tab and call a C vector component. And then I'm gonna add a slider so we can control the thickness of our slabs. So I'm gonna set this one up to 0.4 meters, I think would be okay. And then I'm gonna simply plug in my planar surfaces and my vector over here. So as you can see, we have created some basic slabs. Okay, so the next thing we're gonna do is to take our rotated curves, which are these ones, and move them to the top part of our slab. So we're gonna call a move component. So I'm gonna go to my transform tab and then look for my move component. Then I'm gonna plug it into my curves. And we're gonna use this same vector and distance that we have over here. Okay, so now as you can see, we have our curves located at the top part of our slabs. So now to start creating the glass curtains of our tower, what we're gonna do is to scale these curves inwards. So the first thing we need to do is to create a reference plane for each and one of these curves. So we're gonna go to our surface tab, and then under our analysis subcategory, we're gonna select our area component. And we're gonna connect it to our curves that we have just moved over here. And now as you can see, we have created some reference points. So then we're gonna go ahead and call our scale component. But in this occasion, as I want to have a little bit more of control over the way in which I transform this curve, I'm gonna go ahead and call a non-uniform scale component. So let's go to our transform tab and look for our non-uniform scale component. And here let me switch to my top view so we can see this a little bit better. Okay, so the geometries that we're gonna scale are my curves that I have just moved here. And to set up my plane, what we're gonna have to do here is to rotate them, as we want to avoid any weird distortions when we start modifying our X and Y variables. So we're gonna need a rotate plane component. So let's go to our vector tab, and then here under our plane subcategory, we're gonna select our rotate plane component. So we're gonna use our centers that we have here as our reference plane, and to set up our rotation angle, we're gonna use the same values that we have on our graph mapper, and I'm gonna have to go ahead and use the same expression we did before to transform our values into radians. So I'm gonna go ahead and type my rad expression over here. And then I'm gonna plug these values into my rotate component. Okay, so once that we have rotated our planes, I'm gonna go ahead and plug them into my non-uniform scale component. Then I'm going to go ahead and call a couple of sliders over here so we can control independently the X and Y values of our component. So I'm gonna create a slider and simply make a copy of it. Okay, so now as you can see here, we can scale our curves in a non-uniform way, and what this allows us is to control how much balcony areas we have at different parts of our slab. So you can play a little bit with these values over here. Then we're gonna go ahead and divide these curves into segments so we can start creating the straight sections of our glass curtains. So let's go to our curves tab, and then under our division subcategory, select our divide length component. And here I'm gonna go ahead and add another slider so I can control the length distance at which I want to divide my curve. And I'm gonna set this one up to 2 meters. and I think I'm going to leave my division every 1.5 meters. So let's go back to our perspective view to see this a little bit better. Okay, so these are our division points. And I'm gonna quickly hide some of these geometries to see this better. Okay, so now we're gonna go ahead and create some polylines using these points. So let's go to our curve tab and look for our polyline component. This guy over here. And in this case, I want to make sure that this input is set to true, as I want to be working with closed polylines in this case. So I'm going to right click on it, and then here under my set boolean option, I'm going to set that one to true. And then I'm going to go ahead and plug my points into my component. Okay, so now we've got our polylines, and the reason I did this is because I'm assuming that this glass curtain will be made out of flat pieces. Okay, so the next thing we're going to do here is to extrude these polylines using a C vector. So again, we're going to use an extrude component. So let's go to our surface tab and find our extrude component. And I'm going to also go to my vector tab and look for my C vector component. Okay, and to set the distance of this one, we're going to go ahead and use one of the variables we created on the previous video, which is our floor height minus the thickness of our slab. So here I'm going to go to my math tab and look for my subtraction component. Then I'm going to plug this value into here. And then I'm going to subtract my thickness value, which I think is this one over here. Okay, so now that we have this distance, I'm gonna go ahead and plug it into my vector over here. And then I'm gonna plug my extrude component into my polylines. Okay, so by now you might be experiencing that your computer has slowed down a lot. And this is because this is actually a really expensive functions in terms of computing, as we are creating lots of surfaces right now. Imagine that for each segment that we have over here, we are creating an individual surface, so that is actually a lot of geometry going on. So to see this better, we could go to our display tab over here and look for our profiler widget. And here you can see much better that this is actually a really expensive function, as I told you before. And this will really slow down our computers. So what we could do instead of extruding all these polylines is to simply grab our original scaled curves and extrude those, so we would have much less surfaces being created. And this will allow our computer to perform much better and be able to keep doing changes in a dynamic way. So as you can see here, our component is performing much better. This is something you may want to keep an eye on. Tracking which functions are expensive and how can you temporarily change them will allow you to have a fast definition that you can always tweak and make changes easily. So as you can see here, we can still go ahead and tweak our graph mapper, and we can visualize our changes in a really fast way. Okay, so for now we're gonna keep working with this, but remember here you have our polylines that you can always go ahead and use to represent your geometries in a more realistic way. Okay, so to finish this up, we're gonna go ahead and work on our handrails. So we're gonna do something really similar to what we did with our glass curtains, but this time we're just gonna scale in these curves that we have over here. So let's go to our transform tab, and this time let's try to look for a normal scale component. And I'm gonna move this guy over here. So we're gonna scale these curves, and we're gonna use these centers as our reference plane. Then I'm gonna add a slider, and this time I want to keep the value of this one really near to 1. More or less something like this. Okay, so here we can do the same that we did before, which is divide our curves into segments and then create some polylines with this. So I'm just gonna go ahead and select these two components and create a copy of them. So again, I could go ahead and extrude these polylines. So let's go to our surface tab and grab our extrude component over here. And I'm also gonna go for my vector. Okay, so remember, this is gonna be a really expensive function, so to keep working in a dynamic way, I'm going to go ahead and instead of plugging my polylines, I'm gonna use my scale curves that we have here. Then I'm gonna plug in my vector. And I'm also gonna add a slider so I can control the height of my handrail. I'm going to set it up to 2 meters. And I'm going to leave it, I think, up to 1.10 or 1.20. Okay, so now we have some basic handrails. So now, as you can see here, we have a massing that we can play with. One last thing we could do here is to cool out or remove these two surfaces that we have here at the top of our tower. So what we could do is to call a list length component to know how much surfaces we have, and then simply cool out the indexes that we want to remove. So I'm gonna go to my sets tab and then select my list length component. And as you can see, we have 56 surfaces over here. So then I'm gonna go ahead and call a cool index component and plug it into the surfaces that I want to remove. And here I'm gonna go ahead and add an expression that specifies that whatever value goes into this input, subtract one element, as remember our list numeration always starts from the value number 0. So I'm gonna type here I minus 1. So in this way I will always be selecting the last item of my list. Then I'm gonna go ahead and hide this extrude component. So as you can see, we have removed that handrail, and I can simply go ahead and copy this component and leave it with the same settings and plug it into my other extrude component. Okay, so now I can hide this guy, and there you go. Okay, so I think that will be all for these sets of video, and I really hope you get something useful out of them. Remember, this definition will always be available for you to download, and that you can always make any questions related to this video on the bottom